Okay, good evening, everybody. I've not played co-host to this on this system before, though I have used Zoom before a few times, but I'm going to switch to screen share and run a little PowerPoint if I can get it started. I've got two monitors here, and I'm not sure which one it's going to pop up on, so we'll take it here and see what happens. And before we start, though, I'd just like to say thank you for Nick for the invitation, and also by way of a should I say a light taste to the start. I was very impressed with Nick driving along there in his pickup, especially at the call side. I think that was great. That can only be surmounted by a Zoom meeting that I was on recently with some colleagues, and one of them was next to a lake fishing. So, and he'd got a photograph over the lake of his fishing rods, and suddenly the alarm bell went off, and he pulled in a carp about this big, all live. Anyway, apart from that, so we'll try screen sharing and see what happens. Right. Tell me if this is not working.
Yeah, we can see it. Yeah, absolutely fine, Darren.
Okay.
Tony, sorry.
Right, but when I go to that mode, what can you see now?
It's cut off half the presentation, so we've got half of the screen on the screen in front of us.
Okay, let me just swap. I'll have to swap screens over because, yeah, let me try swapping the screens. Just stand by a second. I'm sorry about this. One and all, thank you very much for joining us, and the illustrious crew from far-flung places. First thing everybody asked me is, why aren't you as old as your call sign? And the reason is because come from the wireless college I used to go to as a young boy, a young lad, and went to sea, and that was the call sign used by the wireless college, which I managed to change over from my previous call sign. So that's where it's come from. Anyway, let's talk about while we're here, QRM. What can I do? Well, there's an awful lot you can do, but let's start with looking at the principal things which we're going to talk about this evening. VDSL, of course, has been high on the agenda for many people and is quite a hotly contested topic. Time-lapse recordings, very useful. Tools for hunting, other sorts of QRM, chokes you've all heard about. These last two, 6 and 7, are the most important things, I think. So if you fall asleep, just wake up for 6 and 7, that'd be fine. Okay, there's no magic fix, unfortunately. There won't be one thing that's fixing your QRM or noise. It's bound to be lots of things. Some are more serious than others. Some you can live with, some you can't. Some you have to do something about. Okay, a selection of sources. VDSL2, of course, is the real problem is because it's on the phone lines, it tends to radiate quite a lot. GFast is the next thing coming along, which is going to, as it says, go faster. LEDs and street lighting, of course, is a well-known problem. PLAs, power line adapters, that means, so for putting Ethernet over power line adapters or your networking your computers. It could be wideband or it could be narrowband. It could be a single frequency or a couple of kilohertz wide, or it could be tens of megahertz wide. And an example, of course, of TV noise coupling onto off-air coaxes and re-radiates from that is also a problem I've come across. Is your noise domestic? Is it within your property? You know, the trick to do: turn off the big switch, and see if it disappears. And if your radio's on batteries, that's fine. If it's running on mains, you've got a problem. Does it change with day or night? Electric scooters, these little battery chargers for the electric scooters that are coming in tend to be totally unfiltered, that we're finding out. Heating systems I can contest to as having a significant effect. Okay, let's moving on. You might have seen some of these slides before, so if you have, my apologies, and it's really sort of building up a picture that I hope you will be able to get a better feel for it. Anyway, VDSL2 is not a good idea because what you're trying to do is put HF down the phone line. And it stretches from 1.6 megs or 1.2 megs or something like that up to 17.6 with various guard bands in between. Okay, talking of guard bands, this is what they look like. Okay, can you see the picture in the middle there with can you see my cursor, by the way? Give me a thumbs up, somebody, if you can see my cursor. No, nobody. Okay, all right. So let me put the marker on. Pointer options, that's it, highlighter. Oh, that's the wrong color, never mind. There's one band there. It goes from 25 kilohertz up to 138 kilohertz, and that's called an uplink. That means it's data from your modem to the system, to the BT system. The D1 is the downlink from the BT system, and that starts at 138 kilohertz and goes up to 3.75. Then there's an uplink that goes from 3.75 to 5.2. Now there is a gap in between these two. Likewise, there's a gap there. So you can see this system has got an uplink, a downlink, an uplink, a downlink, an uplink, and downlink, all the way up. There are many other systems that could be used throughout, that are used, in fact, throughout the world. But this is the one that's been adopted by BT. So going back to the picture again, it's important that you get this in your mind. So the downlink, i.e. what you're receiving over the telephone lines, is coming to you on this spectrum here, 138 kilohertz to 3.7, or 5.2 to 8.5, or 12 to 17.6 megs. So that's what's coming to you. And effectively, your modem is transmitting on this one, and on U1 and U2. Okay. Now this slide, some of you have I'm sure have seen before, but the reason I put it up is because when I first saw this, it was a bit complicated to understand. So I've superimposed this little graphic down the bottom one here, showing the band map, not the band map, the spectrum. And what you've got is a graph here. Down the left-hand side is claimed speed, and on the bottom here is distance, i.e. kilometers. There's kilometers there. Okay, so what they're saying is 10% of premises are using these bands. They're using the uplink 1, uplink 2, downlink 1, downlink 2, and downlink 3. Well, that means they're using that band there, that band, that band, and that band, and that band, and that. They're using all the bands. So therefore, they're receiving and transmitting up to 17 megahertz wide of stuff. So hence, you get a high data rate at that point. So they're claiming 80 megabits for that. Personally, I think it's a bit optimistic, but there we go. As you can see, you get further out to 1 kilometer. You're only using this is distance from the box, by the way. That's the distance from this green box here in the middle of the screen to your house here. This is where you are. Okay, it also depends on whether you're getting it delivered by overhead lines like this or underground lines here. So the distance down here along the bottom of the graphic is effectively that distance there. Okay, because your equipment is inside this green box here. So as you can see, the further away you get at 2 kilometers, you'll be using U1 and D1, U0 and D1 at 2 kilometers. That means you're using these two frequency bands, up 0 and down 1. So hence, they only claim 15 megabit. And likewise at 3 kilometers from the green box, they're claiming 10. Again, I think that's very optimistic, but there we go. So, anyway, I'll be taking questions, by the way, at the end. I think this is your preferred way of operating. So please do jot something down if you want to mention it later on. Okay, this is a VDSL drop picture, should I say, exported from FunCube dongle at my place some years ago. When BT first introduced VDSL in this area, I thought, well, this is fine. I'm not getting any problems. And then this appeared on the spectrum. What you've got here is a VDSL modem. Now, this could be well, it's a downlink band. So it's the exchange data. This is looking at D1. So it's covering 3.4 megs at the bottom, 3.49 to 3.65 at the top here. Okay. So there's the spectrum here. And these are the tones. These are what they call training carriers. And these will be spaced exactly 4 kilohertz apart. Now, it's important that you understand that these are 4 kilohertz apart. When it's operating, the system switches over to having 4.3 kilohertz apart, but we won't dwell on that. So what we've got here is a system that's in training mode, i.e. the BT end is connected, but it's trying to talk to a modem that's not responding. So it's putting out this signal here. And you can see it was on for this period, then off for this period, and on for this period, and off for this period. So you got an on-off ratio of about 19 seconds to 7. What's interesting is you can see these bumps in it. Can you see these bumps in the spectrum here? There's a couple there. Okay. Well, they correspond with some data that's attached to these here. So some low data rate data is being sent on some of these carriers, not all of them. Okay, that one actually there, you can see it's got some subcarriers in there as well. So this is just one type of modem that BT are using. They use lots of different types, so you may not have seen this when it's in training mode. So this went on for several months, and I was just about to draft up a snotty letter of Ofcom, but it all sort of went away very quickly, but which was quite fortunate, and it hasn't come back since. But that's only half the story. So that's what it looks like in training mode on the downlink band. So you can see you're getting these I could actually work between these 4 kilohertz spikes, by the way, but you clearly couldn't work here or here or here because it's got some modulation on it. But you would, or should I say you couldn't work? It's made your receiver appear a lot deafer. So the noise floor has risen effectively. But these ones are discrete sprogs that were popping up all over the place. Okay, so this is the bottom end of 80 meters. If I go to the next slide, this is the top end of 80. So this is the end of the D1 band here that we talked about earlier on, which stops at 3.75 megs. Okay, and there's the uplink band. So this is the D1, coming back to the D1 band again. You can see I've got the same sort of stuff in here with those discrete sprogs and the modulation. I've turned the gain up here so you can see what else is going on. And lo and behold, if you look at there, if you look at in the background, you've got another system here that's generating all these sprogs here in the uplink band, but it's behind that as well. So it's going across the whole spectrum. Now, I don't know what that is. I never did find out, but it had a different timing and a different cycling type thing. So it wasn't VDSL, but it was some other system. It may not have been off one particular phone. It could have been off a different system totally, and maybe not even off a phone line. So I never did find out what that was. Okay, so the modem is in training mode from the exchange, trying to talk to your modem, which you forgot to switch on. And as you go up the spectrum, it's on 20 meters now. So here it is again on 20 meters. All these sprogs in training mode, and it's the on-off duty cycle there is still the same, 19 to 7 or whatever I said, with these sub carriers in there and some of them. That's FT8, by the way. And that's the D3. That's the D3. Again, it's the downlink band, because that's, anyway, I did have lots of others covering other spectrum, but you get the idea. I got this all the way up to 17 megs, right? And this went on for best part of 6 months. Well, they commissioned all their green boxes without anything to talk to. It's a bit like turning your computer on without having a monitor attached to it. So, what do we do next? Okay, this is an example of VDSL in operation. So this is a system that's working, as opposed to the previous one I showed you, which was the system in the what's called the training mode. Again, I've superimposed the graphic of the frequencies at the top there, 25 kilohertz to 17 megs. And this is a slide taken from one of the EMC leaflets put out by the RSGB. So you can see here, this portion here, 5.2 to 8.5. There's 5 megs there. There's 8.5 megs there. So that's a guard band, and there's 12 megs there. So that's another guard band. Okay. So this is the only way you can tell if you've really got VDSL interference, is to look at these guard bands. Or you can use the Letonos, is it, software put out by the EMC committee. But this was done before they released that. So you can see here, this is the noise floor normally, and this is with the system operating, because this band here was not being used for some reason, probably because there was interference at the exchange end, should I say. So you can see here is going from 104 dBs there to 84 dBs at that point. So he's got a 28 dB deafening effectively. So it's like having your receiver with almost a 30 dB attenuator in permanently. Here it's going to be even worse, obviously. So at 30 meters, he'll be hopeless. He'll have a 30 dB attenuator in his aerials. Right. So what can you do about these? Well, right to Ofcom, I think, is the first thing, because get your aerials away from the phone lines. Try a little receiving loop or something like that, as far away as from the phone lines as possible. If you've got a transmit antenna that you can't move, that's fine. But a small vertical even at the end of the garden might help. If you can rotate a little loop, sometimes that helps, but that gets more complicated. But those are things that you can do. What you can actually do is really write to Ofcom and complain. And please do advise the EMC committee when you're doing so. So it's quite easy to do. Just need a FunCube dongle and all that stuff. But in fact, you don't even need that. You need an SDR now, and the software from the RSGB can tell you how to do that. Okay. So what is GFast, which is the next iteration of it? This is an add-on tool to VDSL, which effectively uses the spectrum that you don't use at the moment. It doesn't use at the moment. So it starts at about 19 megs and goes up to anything from 100 to 200 megs, which should really impress the aeronautical people. So that's going to wipe out 6 meters and all of the probably 2 meters as well to some degree. But I come back to the question here: how could you squirt 144 megs down a bit of telephone cable? It just doesn't go very far, you know. So these systems are going to be these runs of phone line. They'll be quite small, so they'll end up with sort of little boxes on masts just outside your house, and with a fiber to phone line conversion in it, effectively. That's what it will probably be. Or you'll end up with with little micro nodes that everybody couples to, just a few houses worth maybe. So it may not be as bad as we think. We don't know yet. Again, if you look at the spec for GFast and VDSL, of course, notches are in the specification, but they're not mandated. Just a word on notches, by the way. Notches doesn't mean that there's actually a physical LNC network in there. What it means is that that bit of spectrum is not turned on, i.e., you've got loads of modulators in those chips and they're not all used, but it's not actually filtered as such. So you still get noise coming out on those frequencies, particularly with PLT as PLA, as I'll explain later. Okay, those close to the cabinets get approximately 2 to 300, within 2 to 3, a few hundred meters, get very fast data rates. I'm talking about 100 megabits and 200 megabits, that sort of rate, quite high. There was talk of Canning G2NF, and then there's talk about reinvigorating it, but I'm not quite sure what's going to happen on that front. Again, we'll have to wait and see. The next slide, I've always put this up because somebody asked me what a green box looks like. So if you've not seen one, this is for you. Oh, by the way, they do come in different colors. Sometimes they're black, sometimes they're separated, not necessarily one like that. I saw a lovely one that was in one of the magazines, and it was a green box and in front of a beautiful flint wall in a little village in Wiltshire somewhere. And the locals complained, so BT came and painted the letterbox flint coloured, so nobody could see it. And I guess a few cars pranged into it there. There we go. Right. Okay. Noise on the HF band. So a summary on VDSL, overhead phone lines nearby, then you will have an issue of some sort. How bad it is, I don't know. Depends on how far away you are from the exchange. If you're a long way away, it'll probably be on the low bands from your modem or from your neighbor adjacent properties modem. If you're if you're close to the exchange or close to the green box, within say a kilometer or 500 meters, something like that, then you'll probably suffer it on most of the bands that we use. Okay, system imbalances. What that means is system imbalances on the line, because you're trying to squirt anything from 25 kilohertz up to 17 megs down this bit of telephone cable, which is designed for DC. So clearly you're going to get some VSWR bumps and humps in it. And wherever you get that, you get radiation effectively from that, because you've got it might be correctly terminated, but along the way, it's got dodgy connections. It's a bit like having a Duff coax connector. When you put power into it, it doesn't like it, or things start happening, or things trip out. Okay, another thing to do is move your modem to be close to the master socket as you can. Make sure all unused spurs on phone lines are removed. If you must use Ethernet cables from the modem, make sure they're screened and or shielded, preferably both, perhaps with choke fitted. But I'll come on to that, something else. Okay, so that's basically VDSL. Those previous and you have to use various tools to find out what those are. And you use that by using these sort of things here. A FunCube dongle will allow you to look on the screen with free software, 192 kilohertz wide. This is a little receiver here, a scanning receiver, hopeless front end, but I can only listen to the audio on that, so it's about 3 kilohertz wide, but it goes from DC to light nearly, or up to a gig, I believe. But and this one is a SDR play, as it says, and that allows you to look at 10 megahertz in one sweep on the screen. Again, the software it comes with is free. So those are the tools that I use. There are various other things you can do as well to help you find what you're looking for, but basically it's about waterfall images. Now, a 24-hour waterfall image is really useful. You can make if anybody doesn't know what a waterfall image, it's like a spectrum display, but in the time domain. So you'll get the picture anyway later on. So a 24-hour waterfall image means that the whole screen is taken up with one sweep with spectrum along the bottom and time up on the left. Okay. And you can see you can have it different colors, you can have it a grayscale. And in there, you can see various structures, common source signatures, modulation profiles. Stop times are quite interesting. So you can see when something starts and something stops. It might be a next door neighbor's central heating. It might be a fish tank or something like that. All sorts of things. So when you're doing this, you have to ignore transients and use quite heavy trace averaging. So it gets rid of all of the normal day-to-day stuff. You're looking for the background stuff that comes up and stays for 20 minutes, half an hour, maybe 2 hours or something like. You don't really care about something that pops up for 30 seconds and disappears, then comes back a week later. But only you can understand that. So you adjust your time, your averaging accordingly. The important thing is to use very low speed waterfall, as I said, which is essential to give you 24 hours on one sheet of paper. Now, the HDSDR software does this quite well. This used to be the only one in town for doing that, but I think there's probably others that are available now. So you can couple those up to your test equipment, which in my case was the SDR Play and the Fun Cube. Now, the beauty about the Fun Cube is you can put it into your laptop and you can take it outside. You could put this into your laptop as well, I guess, but I haven't done that. You can take it, and you can walk around the streets with this connected to it. You might get arrested, but tell him you're in training for something. Okay, so what does a 24-hour waterfall look like? When I first started looking at this, I found this slide from Dave, NK7Z, who's one of the AWL members, which I found very intriguing. So what you've got here is 24 hours down the left-hand side, down here, okay? And that's midday, as it says there. And this is a spectrum along the bottom, running from 3.4 megs there to the top of the American band at 4 megs. So as you can see here, you've got these sprogs here every 20 kilohertz, okay? You look at this thing here. Okay, that is covering 3.8 to 3.820. That's 20 kilohertz wide, that is, that thing there. But if you look closely, you can see it again. There it is there. Oh, and lo and behold, look at that there. You see it there. Look at these down here. All the way along here. Okay. So this is daytime here because that's the middle of the day, it says there. I don't know what that is. He doesn't say, but you will get pictures like this. Now, the heavier you make the filtering, the more of these things you'll get rid of here. This is a 80-meter sideband stuff here. So the heavier you make your filter, notice there's no CW on this. Oh, there is some CW here. But the more filtering you put on it, the less of that you'll see, and the more of this you will see. Okay. Now, what is interesting at this point to me is here. What's happening here? And that's at 1 o'clock in the morning. Something's clearly happening at 1 o'clock in the morning because it affects the whole of the next day. And it seems to coincide with this point here. With that. So, if you find out what that is, you'll find out what that is. If you find out what that is, you'll find out what that is, of course. But what you'll also find is, this is on 80 meters, of course. If you look at another band, you'll find it here. So here is one of those other things there, and this is on 40 meters now. And that goes from about 6 in the morning, 6 in the morning to about 9:30 in the evening. Is that 6 in the morning? That one isn't. 6 in the morning. Yes, it's these ones here. It's these ones because the timing there is correct. So that one there, these little wispy things here are on 80 meters and on 40 meters, but not just once. They're there as well, and they're there, they're there, they're there. You've also got all this other stuff as well. These are quite interesting. You see, there's lots of those as well. There's something else here that's doing that. You can see he's not put quite so much filtering on it here because you've got some CW QSOs taking place there. These are sideband ones here because they're wider effectively. So what you can see here is immediately at your shack and with your aerial, of course, if you turn the aerial round, if you can rotate it, whatever, you'll get a different picture. So you point it in one direction, you get one picture, point it in another direction, you get another picture. When you're trying to take these images, please don't go straight in and trying to do 24 hours. Practice with the software first, otherwise you'll lose it all. Believe me, I've done it more than once. So this is what you can be suffering from. So this is effectively, if you just look at this point here, this is on for most of the day here on this spectrum. This is 7.18. Okay, so it's effectively lifting the noise floor of your receiver by, I don't know how many dBs. It's difficult to tell from here, but certainly that frequency will be a lot clearer than that frequency. So where are we? Okay, that's taken from Dave in the States. This is from my QTH here, and this is 24 hours on 80 meters. It says so at the top, doesn't it? Of course. So this is in the middle of the day on 80 meters here. Okay. It's not very clear here. Those are some weather broadcasts that go off at the bottom of 80 meters in the evenings. What they call a meteor air. If you look closely, in fact, where am I? I'm trying to look at two screens at the same time here. Okay. If you look closely, you could see some tails there. And there's one there as well. It doesn't appear too bad, but there's that there as well. But that's outside the band. There's all sorts of stuff going on here. So it's not too bad considering, but this was taken at a different time to when the VDSL was a real problem here. So moving on. This is the software that I use to this is a screenshot directly from HDSDR, and this is the waterfall at the top. And this is a spectrum display here. This is an audio frequency display effectively. So what you can see here, this is 40 meters here. You can see the VDSL tones there, the individual tones. You see them running down the screen, okay? And the reason they're fuzzy is because they've got modulation on them, as opposed to the training mode. You see them all the way across the screen there. Okay, now, if you count the number of bars between 7 megs and 7.1 megs, there are 23 occurrences. So if I take 100 kilohertz divided by 23, I get 4.3 kilohertz. Surprise, surprise. So it's definitely VDSL because the timing stacks up and it's 24/7. Now, I can see this here because I've set the gain such that any ripple on the noise floor becomes obvious, which is the same as what we saw on the earlier thing. When the modem was in the training mode, you saw the little bumps on it. You have to set the gain because it's only about a 1 or 2 dB bump across these things here. But it's actually affecting it, and it can be a lot worse than that, as you've seen. Okay, so all the other traces that you'll see are chopped down to get more screen room here. Okay, here we go on 30 meters. Again, VDSL tones there, lots of them. You can see how clear it is here. Oh, it's just 30 meters, not 20 meters. I beg your pardon here. So below 10 megs, there's nothing there, so to speak of. This is the Ritty station at the bottom end of 30 meters there. That's always on. This is FT8. Again, you can see the tones going out here. The reason it's sloping up, it's getting darker up here, is because my aerial is not very good at 10.18 megahertz and 10.2 megahertz. It's optimized for down here. Okay. Moving on. 10 minutes on a 20-meter Yagi. Again, VDSL noise, FT8, VDSL noise. Again, I'm sideband operator, so my aerial is not tuned for this end. So it gives you an example of how bad that is, you know. Okay, so it gets interesting now. So this is, again, this was 90 minutes in the evening. I can't, what's it say there? Yeah, 2200 at the top. So it's 2200 here. And, 2300, yeah, it's about an hour and a half. So all these things are popping up all over the place here, across the band here. This is 14 megs is there. 14.3 is about here. This is the whole of the 20-meter band. So you can see all of these discrete sprogs here with 16 kilohertz spacing. This is somebody's monitor here, 60 kilohertz probably, could all be your own. Look at these things here, wandering all over the screen. But they've got some noise attached to them as well. You can see some noise attached to them. Just look at that shape, okay? Right, moving on. Okay, we're down up to 10 hours on 20 meters. And I've compressed that. So that's midnight there. And this is 10 o'clock in the morning here. So again, you've got those 16 kilohertz spikes. So this is on all the time. You've got all that stuff there. I didn't have enough filtering on here because I'm getting some CW coming through. I didn't realize at the time I could have put more on. But again, you've got all these tails here, which are all across the spectrum. So it might be worthwhile looking at those in more detail if that's a major problem for you. This thing's switching on and off. I can tell you this is a central heating system. I know it is because it was mine. And it's probably true to say that majority of your problems will be in your own property or next door. Okay, what did I say here? Two frequencies coming from the same source as the times coincide. Yes. Yeah, when one stops, the next one starts. In there, for example. That one stops and this one starts, or it's the other way around. So you can see where you get a coincidence of events in the time domain, they're probably linked. Okay, this is 17 meters, which is 18 megs, which means no VDSL noise. Hooray! Yippee! Again, this is looking at other monitor. 2 o'clock. Yeah, it's not long. This is about an hour, I think, at the most, up and down here. So again, you've got monitor sprogs, but again, you've got these 28 kilohertz things, and they come from my next door neighbor's central heating system. I know that for a fact. Because I can put the my little receiver next to on the wall adjacent to his central heating system, and it goes bonkers because his central heating is in the extension to the house, which is right next door to me. So this is the sort of stuff that you can find out with all those little toys. I'm sure lots of you have already got those devices. So here we are again. This is 15 meters. Again, you've got the on-off pulses here showing the timings. And this gets quite messy, this one here. This is 12 meters. What I find really interesting is here, at this point here, at midnight, the PLT system in one of the adjacent properties here went off, and it started to do a resync, and it spreads across the whole spectrum. See this stuff here? Whether it does it every 24 hours or not, I don't know. But this is a wandering power supply, like a lost soul. You can tell it's a power supply because it's got loads of crud on it. And again, you've got these discrete sprogs here, the 16 kilohertz things. And yeah, they're a bit weak, but you can see them here in that area there. They're more evident. And you've got these little spiky bits here at 20 kilohertz. Okay. Noise on the HF bands. I had a unique signature on that covered 14 and 28. But it was also very weakly resolvable on 50 megs. So I managed to turn the beam round and point the 6 meter beam in the appropriate direction. And found it, and then went out with a mag mount on the car, and it turned out to be the local council offices, or one of the council offices. And I went in there and said, your thing's causing me problems. I did actually say I was doing moon bounce at the time, which wasn't strictly speaking true. So just to give you an example, so harmonics of QRM are really good clues to DF, to finding it. And the reason I use the little single loop, by the way, coming back to one of the earlier slides, but where are we? Where's the mouse gone? Ah, there it is. The reason I use, whoops, this one here is because you can get a really good null on that. So you can get a very deep, precise null. And you know exactly then that the bearing is coming from that particular direction. And it's not like trying to tune for a peak. A peak can be quite broad. So you might end up with, it's coming from that rough direction, which might be 20 to 30 degrees wide. with this, when you're going for the null, it can be extremely narrow. I'm talking tens of degrees, maybe 5 degrees wide, you know. So back to where I was. That's why I like that. Okay. So noise on the band in the shack, USB dongles, 232 dongles, often used. Lots of well, not lots, some QRM due to unscreened and poor leads. I've got a box full of goodies here. I'll show you afterwards when the camera's on. And in there's some real culprits. USB connectors are really prime candidates for this because the shielding is not very good, by the way. The plating tends to mean that you get a very high impedance ground, if at all, if you get any ground. If you take your DVM and connect one end of the USB cable to the other end of the USB cable, it might be 100 ohms or more. And if you scrape off all the stuff on it, you might get a decent connection. So when you plug it into a computer, you don't have a braid connection. You don't have a ground connection. You just have the 4 wires with all the data whistling up and down. Okay. So cables do radiate as well, and Ethernet cables are an issue. Despite what people might say, I found them to be an issue. Once you cure the boxes that you use, your network switches, etc. Okay, I've written down a little hint with if you're going outside to look for noise that you can see or hear at home, then try and get a recording of it, a sound recording of something or a visual recording of it, and compare it with what you're hearing and seeing, because you will find lots of other sources that sound the same. Are they the same? Are they different? You've really got to be sure when you can start, if you're contemplating banging on somebody's door, that you've got the right point here. So please, I do suggest you record it and then play it back and then take it, see if it sounds the same if you're listening to it on a speaker, or if it's a wideband thing, look at the signature on it. See if you can make the signature match. Okay. Okay. What can we do on that? What can we do at home? Mitigating actions. Antennas first. Okay. Avoid N-fed antennas into the shack. You can use N-fed antennas if you terminate them outside and bring coax back into the house, which means you must use a balanced or a remote ATU of some description. Locate antennas away from buildings and metalwork. Common mode chokes on all antenna feed points. Now, Steve SEK has done, not Steve, Ian SEK has done a lot of good work on this, and TXQ Steve also did a lot of good work on that, and this has brought us to the current understanding of the game. So we really do need to put common mode chokes on all the antenna feed points. Again, my presentation at the end, you'll see that. And ground metallic structures close to the noise cancellation devices are okay, but wideband loops for receive can help. Yeah. But the most important thing here is get the best earth you can. And secondly, decouple all external lines to your RF earth. That's the most important thing. If you don't come away from here tonight with anything, just remember those. Right. Coming back to common mode chokes. Right. Why do you put common mode chokes on your cable? Okay, as I said, Ian and Steve did a lot of good work on this. This is one of Steve's chokes, by the way. From his website, he's got the formula there, and it's effectively one of the ones that he did. Anyway, if you take the formula, put it in Excel, this is what you get. So what you can see here, the reactance here, okay, is going through 0 at this point here at around 9 megs. I don't know how many turns or what the core is, I can't remember, but it doesn't really matter. But so this allows you to actually plot the core, or shall I say the common mode choke that you want to use to see where it's optimized for. So here you've got a high value of resistance and a high value of impedance here, and a low value of reactance. So this makes it an exceptionally good choke at this point. It makes it pretty naff down here. Okay. So what you want is a low value of X and a high value of everything else. So this choke can probably work up to about 15 megs, maybe a little bit higher, from about 5, because that's going from 5,000 ohms there up to 10,000, maybe 4 megs up to, but you've got to remember that you could effectively invert that lower trace there and put it on top. Instead of that being negative, being capacitive, it could all be just ohms. So that'd be up there. So you can see here that effectively it's only good over, it's good over effectively what I've shown there, this point here. So 5 megs here, you've got a 2-to-1 ratio of resistance over impedance. So at 13 megs, you still got that 2-to-1 ratio. It's starting to drop off a bit here, and here at 20 megs, it's pretty grim. So wind your coil. If you've got the equipment to be able to measure S parameters, do it, and put it on your put it through that formula, get the pretty pictures, and decide which one you want to use. Or you just take the cookbook solution that's on their website, which works reasonably well. Although the new material 31 does have some advantages in some cases. Okay, earthing. Everything in the, a good RF earth for this shack, and ground everything to this. A minimum of 2 to 3 earth rods, spaced about a bit, but effectively you need a low impedance to real ground. That's what you need, a low impedance to real ground. So you need a half decent earth rod. Now people say, well, can't I use a radial field? You can do, but you've got to remember, a radial field is designed to have capacitance coupling from something above it. Okay, so it's designed to take the ground losses down in that area underneath your antenna. An earth rod is designed to take that current and dissipate it in that area. If you don't use a ground rod, then you're effectively decoupling to a, if you've got nothing else, by the way, I would use a radial field, but that can also radiate from that point. So you don't seem to get the best benefit from that. Okay. Secondly, add further chokes to all coax cables, additional chokes apart from the one at the top at the feed point where they enter the building. Okay. So what this does is forms an L attenuator with the ground systems. Okay. Again, this will become apparent in the next few slides here. Don't disconnect the main earth line unless you get an electrician to do it for you, who's going to put in a Pacific RF earth for you. Some people have done this, I know, and it works really, really well. But just remember, 50-volt earth currents may well flow, prefer your earth in preference to the designated path. People say, well, I wouldn't do that anyway. But if you think about it, you're already doing it, because when you plug your radio in, if it's got a power supply, okay, the 0 volts of the power supply is connected to chassis on the radio. Okay, the 0 volts is probably connected to ground as well on your earth tag, again down the mains lead. So that means the outside of your coax is at earth. And if you're going to ground that outside, you've still got another earth that's attached to your main electrical earth. So just bear that in mind. I'm not sure if I made myself clear, but if necessary, let me know. Okay, so what you've got to do, you're going to tidy up the effectively the mains coming in by filtering it using a whole shack filter. This is the sort of thing here. So on the left hand side, we've got your supply coming in. It goes through a filter of some sort, this thing here. Okay, and that drives the whole station here. Everything in your shack, every single thing apart from the lights. Okay, try and avoid having anything else connected to your earth system here. So what you're trying to do then, there's the earth pin here. Okay, it comes down here. It goes through this earth line choke to your shack earth here. Now you can buy these filters here on the right hand side that have got earth line chokes built in. In fact, if you look there, where's my cursor gone? Oh, there it is. This one has got one built in just there. Okay, there's an earth line choke in there. So that's what you want. But I'm sure 10 amps wouldn't be enough for you. So you might have to put 2 of them in. But so what you're effectively doing is the noise that comes down here will be impressed on this point here. There's no doubt about it, because particularly if you've got overhead cables, well, it doesn't really matter in that respect, thinking about it. But you've got noise on these, and you've got the same noise will be appearing on your earth pin, because the wires are so close together, the capacitive coupling is quite high. So what you want to do, you've just filtered this here with a live and neutral. You want to stop it going down the earth line as well to your, you don't want that noise there flowing in here, do you? That's the last thing you want, because that means it's going to develop a voltage here, which you're going to get onto your coax. It's going to be on the outer at some point, I agree, but then it's also going to be on the inner as well, and that's when you'll see it. So assuming you, that's of course assuming you don't have a filter here that's got an earth line choke. Most of the filters don't have earth line chokes nowadays that you buy, so you may have to resort to this thing here. You can do a DIY choke, but make sure it can handle 16 amps. You can see this one here is for sale from this company here, A Shirter, and that's its number there, and they were charging £12 for it. So it's just a bit of ferrite with a couple of turns on it, but it gives you an idea that you want 20 microhenries, and it's got to be a fat conductor, and you've got to be careful using a toroid here, because it could quite easily saturate if you do get any issues with that. But there should only be a few milliamps flowing down here at worst case. Okay, the other option then is to go to Amazon, and they do these earthline strips. So it's a 6-way mains block with a 3-pin plug at the end and a bit of cable, and it's got a filter built in here. So you can see it's got some transient suppressors here. It's got some decoupling capacitors there across the phases, just like this one up here has. So you can see those there. And there's the toroid, just one of them in this case, but the top one has got 2, so the top one gives you a much better specification. So it's worth trying. A lot of people have used these and they're quite successful, but they used to be £36 for a little 6-way one. It might be rated at 13 amps, but I wouldn't want to run it at that for long. So, okay. So we're now moving away from the mains noise. So we just cleaned up the mains side here. We're now moving on to the shack here. This is where the fun starts. And this is a picture of my shack. I know it's a bit busy, sorry about that. But if you just look at this line here, this is the brick wall between my shack and the outside world here. Okay, so everything to the right is in the antenna garden. Everything to the left is in the shack. Okay, so here we have some buried earth rods here. Okay, and there's 1, 2, 3 of them. There's 4 in fact. 1, 2, 3, 4. There's another 4 there. These are couplers, of course, it says so. And a copper pipe that goes right across here. And it goes right through the wall. This is a water pipe. I think it's 25 mil, something like that. And it couples to another water pipe. There's no water in this, of course. And it goes up and down there like that. Okay, that is my RF earth. Don't get confused between that and the electrical earth, which is coming down your sockets here. So I've shown here an earth line choke, a filter, AC power distribution. So that goes to all of the other power needed devices, be they DC power supplies, radios, amplifiers, PCs, other little power supplies, you name it, rotator. Okay, so you've effectively got another L network there, so an L attenuator. So your signal comes down here, sees this impedance in the way, okay? So it doesn't flow through it because this is ground here. So there's very little of that noise on the earth line going through here. So it doesn't effectively modulate this ground voltage. So this will have some impedance to ground, to real ground, of course. It must have. And what you're trying to do is to stop this wobbling up and down with RF, okay? And the way you do that is to put some impedance up here. So you've got an L attenuator. If that's not clear, please sort of sing out later on. The same thing applies from the antennas. Here's your Yagi, and here is a common mode choke that I've chosen specially to match this frequency band. And the coax goes all the way down there through the hole in the wall, and there's another choke here. Now this doesn't have to be the same choke as that. This one is a much broader band one, okay? It only needs to be a few hundred ohms, if that. Maybe 500 ohms would be plenty, okay? And that is going around the outside of the coax. Sorry, that's going through the coax, and it's multiple turns around there. There might be 5 or 6 turns on that, and that'll be using these. Oh, you can't see it, can you? I've forgotten. That'll be using these rectangular cores.
Tony, we can see you, by the way, so you have.
Oh, okay, sorry. That's these things here. If I'd known that all along, that's these things, right? Here's an EMC filter. Okay. Taken out of a washing machine, by the way, so don't bin them when they've gone past their sell by date. This one is rated at 15 amps, so that's useful. Yes, right. So what was I talking about? Okay, so chokes at this point here. So the outside of the coax is then coupled to this mammoth earth plane here, which is connected to my 2 earth rods here. And everything else in the shack is also connected to this point here. So active antenna, the LF stuff goes through here. The rotator comes down here. All of the rotators, of course, don't have screen cables because they just don't make screen cables for rotators. So you've really got to decouple all of those components with capacitors. A choke is not going to do it for you. So you need 100N or 10N on each of those rotator lines there to ground, coupling directly to this ground pipe here. You can use Jubilee clips, whatever you like, anything that's convenient, but just make it sure it's a good solid ground point for all of these cables coming in. So so the idea is to keep all of the currents, to prevent the currents from producing a voltage on this earth line here. So prevent the radio ground from moving up and down, okay? Whatever you can do to help that will improve matters. So that's basically it. That in a nutshell. I've rushed a bit over it because well, it's too much to cover, and I usually run out of time. So noise on the HF bands. That's just the tip of the iceberg. Obviously, there's a list here of things which I found useful here. And what's as I said here, what's the number one takeaway? Oh, why isn't it working? Has it stopped? Ah, that's it. Sorry. I don't know why it stopped. Okay. So that's the most important thing to do. Here's a picture of some chokes. And that's it. Right. I'm sorry that was a bit rushed. And if there's anything you want to
No, that was brilliant.
talk
Thank you,
about.
Tony. That very good. And apologies, I didn't point out to you earlier that we could see you, and if you wanted to hold things up. So
Well, can I do that now, by the way?
yeah, go on. Yeah, go on. Hold up a few other bits. Yeah.
Okay. Let me talk about USB dongles here, cables. Here is a USB cable. These are my bad boys here. It's a USB cable here. It's got an A at one end and a B at the other. I don't know if you can see that. Okay. And this one measures about 90 ohms on the braid from there to there. Here's a 232 converter. Oh, that's better. Here's a 232 converter, and that is not connected to that at all. That's open circuit. There is no connection between the braid of the USB to the braid of the D type, and it's not even connected to pin 5 either. There's another USB to A, and it's all to do with the plating. Okay, it's all to do with this plating and when you plug it in, so you don't get a good connection. Many of them I've got are 1 or 2 ohms, and some are, 90, 100 ohms and stuff like that. Okay, USB Ethernet cables. I always use Ethernet. I use Cat 6 around the house because I've got a short run. The reason I use Cat 6 is because it's shielded, and it's about all you can buy nowadays. It's any good, and it's got a metal bit here. Can you see the metal bit, the shiny bit? Okay, that means it's got a screened cable. They wouldn't put that on unless the cable was screened. There's no point. There's nothing for it to connect to. So there's one at both ends. So it means that screen is connected to that screen. Just get your DVM and make sure it's connected. Okay. So who's got a network switch at home that they're using their shack? Hands up, everybody. Okay, does it look like that at the back? Has it got a metal bit there? Okay, so my Ethernet cable plugs in there like so, which is great, except that metal bit doesn't go anywhere. It's open circuit. It doesn't do anything. Don't use a metal cased modem box. Router box. Use a metal cased one and make sure it's properly grounded. Okay. Here's a earlier Cat 5 that's I found sculling around. Clearly, it's not got any metal bits on the outside, so I wouldn't use that for anything. This is the worst switch mode power supply in the world, because I put all those on it and it's made a blind bit of difference. So that came with a Netgear router. Okay, and we recognize these phone chargers. Okay, the reason I bring them out is because phone chargers, the modern ones, are quite good actually, but as an example, I use them as an example. So what you've got in here is an oscillator, effectively. And here's a bit of wire that's connected to it, okay? Now, if the oscillator's running and it's like that, it doesn't radiate very much. You might, a little bit might go down the mains cables, but not very much. Usually it radiates off here. So it's anything that you've got plugged into the phone charger. Now, let's imagine this is it here. So you've got a 50 meg clock in here. In fact, you've got several clocks at various frequencies. And when you plug your Ethernet cable in, like so, they radiate from the outside of the outside of this. The reason they radiate is because they're not screened, and the Ethernet specification is not about what radiates. It's about the speed down the cable. So you can get a cable that goes at 600 megs or whatever it is, which is great, but they don't. The specification is not about the shielding or anything like that. It's about the speed of the cable. There's loads of other things here. This caused me some grief as well. Laptop port expander, a little thing. Anyway, I've got loads of other things that I didn't bring out from the shack. So without any more rabbiting on from me, any questions?
All right, brilliant. Thank you, Tony. Yeah, we'll throw it open to questions. Lots of food for thought there, Tony, on a whole range of things, and very, very interesting. So who wants to go first? I'll just so I can see people wave at me on the screen. Yeah, Gerald. Go ahead, Gerald.
Oh, yeah, thank you very much for a splendid talk. Very simple question. Inline mains filters, best location for them, by the consumer unit or near the shack?
Inline mains filters should be by the shack, or depends what you're trying to do. Are you trying to stop noise coming out of the mains or trying to stop noise getting into your equipment?
Same thing. Stop.
Well, it depends. It depends where your line unit is.
Right. Consumer unit is about 60 foot from the shack.
Okay.
Which is at the other end of a long, thin bungalow.
Okay.
Which at the moment is just hooked onto the ring main, right on the end of it.
Okay. Well, I would put it at the far end.
Which far end?
Okay, but you've got to make sure then that you haven't got anything else locally that's putting noise onto it.
Yeah.
From
I was
your end.
looking at running a feed down. The shack's basically a spare bedroom. Got a long, narrow bungalow. It's exactly 20 meters long.
Right.
And I was looking at running a separate circuit down to the shack.
Yes.
Obviously, it's easy to incorporate filtering, but just which end? You say the consumer unit end.
Yes, I would put it there. But yeah, I'd put it there. Thinking about it.
Which then gives you 15 meters or so of twin and earth that can pick up everything going.
Yeah, but it's the other way around, isn't it? If you run the cable outside and you put your impedance at the far end, it can radiate off the other bit that's exposed.
Yeah. Well, the cable will be through the loft, in fact.
Okay.
Yeah.
Oh, in that case, if it's up in the air, might be better to put the other end. I don't think there's much in it, to be honest.
Yeah. Okay. Thank you. Seem to have lost all this.
All right. Thank you, John. Gerald, you were waving. Gerald, you're muted. I need to unmute.
Is that better? 1, 2, 3.
Yeah, that's fine.
Okay, sorry about the delay. Right, thank you again, Tony. That was great. And trying to write notes as well while he was saying it to make sure I don't do anything wrong when I start myself. At one point, couldn't you put a high voltage capacitor, say 100 puff or greater, between the mains earth and the shack earth in order to isolate the two to the normal mains sort of voltage stuff, but at the same time let the RF flow through for the two earths to connect them for RF point purposes?
Yeah, you could, but I think you'd be breaking the law.
Oh, well, I've done that often enough. But
Yeah.
is it classed as
Yeah, we've all driven over the speed limit. Yeah. The idea is not to open circuit the safety earth.
Oh yeah, yeah.
Now
Okay.
you can put an impedance in the way. In fact, that slide I showed you with the little filter, the little inline choke,
Mm.
little black thing on that
I
slide.
remember that.
The company that sells them make alarm panels, and in their advertising blurb they say fit one of these if your alarm panel is going off randomly, because it's probably due to a local radio ham.
No.
So I thought, well, these are ideal people. They obviously know what they're talking about. So,
probably got a license as well.
but you shouldn't really open circuit your earth unless you've got an electrician to put on in for you specifically.
Well, our electricity is quite old-fashioned anyway, but that's another issue.
And well, you need to be sure also whether you've got PME or not, because that has various implications that I'm not sure of.
Ours isn't PME; it's a much earlier version. The house was built in 1948.
Oh, okay.
Gives you an idea. It's not all that new. But
have you got an earth?
Yeah, on a similar vein, some of the ICOM radios, they come with a power supply filter fitted to them, which seems quite effective. But it's in the DC side. It's between your mains transformer and the radio itself. Well, that will keep a lot of the RF that's in the mains out of the radio, won't it?
It should do, yes. Should help anyway. Yeah, but again, it will only be filtered to meet the regulations on noise that's exported from the box. It'd be a switch mode power supply, you can be sure.
Oh, I see. Yeah.
So I would always be suspicious, of that. And you don't know if the ground is actually connected to, if your 0 volts is connected to ground, for example.
No.
It might be worthwhile checking the chassis of your radio. Does it go to earth through your 2 wires back through the power supply, or is it floating?
Yes, that's true. Well, I'll check it, but as far as I'm aware, the earth does get there, because I've got a shack earth here as well, and I check that against whatever else I've got with my meter to see if there's a voltage there.
Okay, but it's 12 volts, isn't it? So you can get away with that, can't you?
Yeah, but if it's coming through a power supply that some manufacturers made, you don't know whether the earth is connecting through or not.
But if it's 12 volts, you don't have to have it connected, I believe.
All right.
Because it's only if you've got mains flying around inside your box. If you've got a rig that's got a 3-pin mains plug on the back of it, that's when you've got potential for having a short from a live cable to the chassis, and that's what it's trying to avoid there.
Yeah, I see. Okay.
But I would still make sure that if it's a twin cable, you're probably better off if you've got a remote power supply.
Yeah. Most of the stuff runs on 12 volts here, I think, apart from the old 101, which is mains.
Yeah. What I've also done, which didn't come across on the slides, was I got rid of all of the Ethernet cable to the shack, and I use a fiber optic link back to the modem, which is in the main house, and that works a treat because it's RF proof, and it's impossible to get an earth loop, and that's what I was trying to avoid. So I've got no other connections apart from mains into the shack to avoid this earth currents business.
Fine, that's good. Yeah. Right. Okay, thanks anyway.
Lovely, thank you, Gerald. Who else has got a question? I've got a couple online. Yeah, Darren. You need to unmute, Darren.
Yeah, sorry, Nick, you muted me earlier. I've got problems with the dogs. A lot of fireworks going off, so they're not too happy. I'd just like to back Nick up on looking at reorientating your aerials. I've just put a couple of videos on the Demberdale website from an experiment I did about 12 months ago. My main aerial used to run off the gable end of the house, mainly because that gave me a height advantage. I put a portable aerial halfway down the garden, approximately 10 meters away from the original center, and you can see the difference online. It literally on 80 meters, I think, goes from S1 to an S9. The S9 being the one on the house, and the S1 being the portable aerial.
Yep.
And I think on 40 meters, it goes from again something like an S1 or 2 to about an S5 or 6. Again, the portable aerial being the better one. So as you can well guess, I've moved my aerial now. So that's definitely worth doing. Even if you can't move the center, just move it 45 degrees in the line. It can really make a difference.
Yeah, if you've got space, then use it.
I know.
And get all the aerials away from the buildings.
Not everybody has, absolutely.
Yeah.
And again, I put a few years ago, I put some decking down, and before I put the decking down, I think I sank about 12 earth rods and interconnected them all, so it looked like a spider's web for the RF ground, and that made a massive difference as well. So on good days now, I've got virtually a flat level background noise.
Okay, that's good. Good, well done.
Okay, brilliant. Thanks, Darren. Right, yeah. Who else? Go on. Yeah, Jeff.
Okay, good evening. Thank you very much, Tony, for a very nice and interesting talk. I have actually two interconnected questions. How do you get a good ground if you are living in an apartment on the 4th floor, and is any artificial ground that you can buy? These magical boxes, does that help anything?
It's always a problem when you can't get a ground. The best thing I can suggest is try and use balanced antennas, which again makes life a bit tricky. So I wouldn't go for I would use a dipole or a loop or something like that if possible. If you go for a vertical, it's going to be tricky.
Well, I have a small balcony.
Well, you can, people have done it by dropping quarter waves down for each of the respective bands, trying to use, but that forms part of your aerial as well, you know. So I saw a video once where a guy had actually done it in the house, and he'd run them down the stairs, you know, the cables, you know. I don't know how his wife got on with that. But not impressed, I expect. There we go.
Thank you, Tony.
I'm sorry, I can't offer any. Which brings me to another point. There are things you can do if you've got an upstairs shack. It's not nice, but you can do it. You can get this aluminium foil that you put in a loft that's got bubble wrap on one side or both sides to help for insulation. So it's an aluminium strip. It's about 1 meter wide. Okay, it's protected by bubble wrap. Okay, yeah. You can ground to that. So it's quite low inductance. So you could put 10 or 20 feet of that in, and it's still a reasonably low impedance at the top end compared to the from the bottom end.
Okay.
So, but if it's 4 stories up, I'm not sure. Or if you're on the 22nd floor of a tower block, it's a bit hard.
Well, a good view for VHF, but not for grounding.
Yeah, but
okay.
you don't need ground much with VHF from that point of view. You know, you can get away with that. But yeah.
Brilliant, thank you, Jeff. I've got a couple of things that people have raised online, Tony. Joanna makes a point, and I'll just read it out for you, Joanna. Be careful about dissimilar metal connections in your ground system. When they corrode, rust, and they will corrode, a junction's formed, and the junctions will make passive intermodulation PMI
Correct.
products from the currents in the ground system. So she's just giving a bit of a warning there about how
Yep.
you connect to the ground system.
Yeah, that's true. Yeah.
And a specific question to you was from Keith, who said, could you please say something about the problems of overlong earth cables, signal noise pickup?
Overlong earth cables. Well, they go open circuit, don't they, at a particular frequency where it becomes a half wavelength.
Mm.
So it doesn't, if you've got put it this way, supposing you've got a medium wave transmitter just down the road from you, and it's on some frequency other, and your bit of earth wire that you've put in happens to be a given half wavelength at that frequency, it's not going to you're going to induce a lot of RF into your earth system. Or when you add it to all of the other stuff that you've got hanging on the end of it as well.
So Keith's point is that it is actually effectively therefore bringing quite a lot of noise or signals into the shack from the earth line if you've got a long earth lead, particularly if it's a multiple of one of the
yeah, but if the earth lead is there for safety reasons, then you can still put a choke on it and have another earth locally, which is effectively what I was alluding to. So you're choking off the RF effectively. It's coming down the earth cable, this long earth cable, and it's not being imposed on your equipment. If you connect it directly to your local earth, or even if you don't have a local earth and you connect it to your equipment's going up and down like with all the RF, isn't it?
Okay, thank you. Right, anyone else got a question to Tony? If I don't see you, just unmute yourself and raise it. So anyone else got a question? Yeah, go on, Gerald, you've got another one. Go on, supplementary. So, you had to unmute yourself.
Another quick one, if I may. Sorry for the delay, getting the button pressed on the microphone here. And that was when I've got a number of laptops in the shack, and they don't seem to be earthed by the little mains power supply that they have, or anything like that. So, is there a best way to get to an earth for the laptop? I was wondering whether I should take a little wire from the power supply lead where it goes into the outside of the circle or not, or is there a better location?
It depends. If you've got any connectors on the back that are sensible, you can get to the chassis. In fact, I did have an issue with an earlier laptop of mine it was an old ThinkPad that I used to use, and I found that but it did have a serial port, I think, on the back, a metal serial port connector, so a D-type, so I could use that, and that cured all of the sprogs. But what you do have to watch out for from laptops, and in particular, is the mouse mats, because they radiate like a trooper. They really do. So, as a word of warning here, if you're going on field day and you're in the tent or whatever it is, and you take a laptop that's got a excuse me a minute. Here's one I prepared earlier. Here's the keypad. Okay. Whoops. Here's the mouse mat. Effectively, you just put your finger on it and squiggle it around. You know the drill. Okay, this is a capacitively scanned matrix under here. Okay, so that means there's a load of wires going that way and a load of wires going that way. And when you put your finger on it, it affects it where the wires are crossed, so it gets couples. So there's lots of signals on those lines. Okay. And those signals, when you put your finger on it, radiate on the spectrum. And I've discovered it on my own laptop. You could see it as I was running one of those programs I showed you on here, I was thinking, when I touch this, it suddenly goes, because the aerial was close by.
Yeah.
And it's actually radiating from this bit here. And it does cover a lot of the HF spectrum, by the way. It's not too bad. It's like that. But as soon as you touch it, you know, it radiates tremendously. Most of them seem to do that because that's how they work with this capacitive coupling thing that's got a scanned matrix.
So better using an external mouse.
Yes. Yeah. Or a USB mouse. Yeah.
Yeah.
Okay, thank you, Gerald. Yeah, go on.
I'm just going to ask, so presumably put some foil over that thing and stick it out. I hate it anyway because my hand often catches on it and suddenly the mouse thing flies in another direction and I'm trying to type on the keyboard. So
Right.
I'd like to cover that up.
Well, get a wireless mouse, 2.4 gigs, you know.
Yeah.
That's what I use. You can, this is the Bluetooth dongle here that goes with this. Okay, you just plug that in and that's effectively your mouse. That's much better. But if you're in contest mode, you should be using the keyboard all the time, shouldn't you? Shouldn't be using the mouse.
Yeah. Yeah, that's the
I still not mastered that yet.
Contest when I'm using the keyboard and I keep catching this silly little thing down here and it moves the mouse around and next time I'm trying to type something, if I'm typing it somewhere else on the screen.
Oh, I see. Okay, it's.
I want to cover it up, but I was wondering putting foil under it to make sure I can earth it and screen it. So
No.
But I do have a wireless mouse.
Can you? I would go into the BIOS or turn it off or something like that if you know how to do that.
Yeah, I could do, but I just haven't quite got around to it yet.
Yeah. Okay. Well.
All right, brilliant. Yeah, thanks for that, Gerald. If no one else has got a question to Tony, yeah, go on, Ray, M1REK. You have to unmute.
It's not a question, it's just an experience. A friend of mine asked me if I could go around. It all of a sudden had got real bad noise on every band. It's S9 noise. So I went down with a little DF loop and a laptop and the SDR. And we traced it to a house and it was really booming in from the house. And we knocked at the door several times and nobody would answer the door. And so we sort of wandered up and looked in and there was a little crack in the blind. And what we could see through the crack was UV light shining down onto a cannabis farm.
Yeah.
Which had been set up in a rented house. So we went back, called the police, they were raided, shut down, and that was it. It was gone.
Yes. Yeah.
It was a quicker response than Ofcom then, so, right.
Yeah.
Was, yeah.
Very good. I wish they were all that easy.
Yeah. Excellent. Well, look, can we, if no one else got a question to Tony, can I, on behalf of the club, thank Tony very much indeed for a really interesting talk tonight and show our appreciation in the usual way as you would do at a meeting. So cheers, Tony.
Thank you very much. Okay. Well, if you've got any questions, you'll just drop me a line.
Okay, brilliant. Yeah, well, I'll when I post it up, I'll post up your email, Tony, if that's okay. And if anyone's got any questions, I'll get them to contact you. So thanks very much indeed for really interesting.
You're welcome. Well, thank you guys, and we'll see you again soon, I hope.
Good. Thank you, Tony. Right, everyone else, we've got to that moment where I think we've actually finished the formal bit of the meeting. Let me just turn the